Welcome to the square root of a function. The square root of a function y is equal to f of x can be thought of as transformations of the points y is equal to f of x that are mapped into y is equal to the square root of x. Now, when we see y is equal to the square root of x, we just call it a square root of function. But in mapping notation, what we see is that if fx has point xy, so this point here might be on fx, so if y is equal to fx, has point xy, then y is equal to the square root of fx will map into point x comma the square root of fx. Or, probably simpler, y is equal, or x is, pardon me, xy maps into point x comma square root y. So really this notation, to get the image point, we just have to keep the x the same and take the square root of the y coordinate. So here are some interesting facts to keep in mind. That is, the square root of a -1, the value does not exist in the real number set. We can even extend that. The square root of any negative number does not exist in the real numbers. The square root of 0 is 0. So the square root of 0 is the same. The square root of 0 is the same as 0 itself. Now, the square root of some number, x, is greater than x. For all x in the set 0 less than x less than 1. In other words, if you take the square root of any number between 0 and 1, exclusive of the endpoints, the square root will be greater than the number. That is, the square root of 1/4 is greater than 1/4, because the square root of 1/4 is a half, and that is obviously greater than 1/4. Square root of 1 is 1, and that's going to be important, so it remains the same. And in general, the square root, last but not least, the square root of x is less than x for all x where x is greater than 1. In general, as x increases, the square root increases. All right, this is not really anything new, but it's number sense that we may have forgotten about. So I'm just going to describe the value of fx, or the y value, and I'm just going to do the description of the behaviors of the graph. So when the y's are negative, the graph of y is equal to the square root of fx is undefined and does not exist. If the y value is 0, now keep in mind that we're taking point xy and we're transforming it to point x comma square root y. So when y is 0, the graph of y is equal to fx and y is equal to the square root of fx have stationary points on the x-axis. Basically, we have a stationary point. So for a point x0 that is on fx, when we take the point, it remains x comma 0 on the square root function, y is equal to the square root of fx. Now, for any y value that is between 0 and 1, excluding 0 and 1, the square root function will have a greater value than the regular function. And that's because the square root of y, or fx, is greater than than fx, or the y value itself. If fx is equal to 1, moving on, the graph of y is equal to fx and the graph of y is equal to the square root of x will have stationary points whenever. So I like this because my point will remain the same, and we call it a stationary point. Now, whenever fx is greater than 1, like, I don't know, if y is 4, for instance, the graph of y is equal to fx will be less than or lower than the graph of y is equal to fx. All right. That was a lot of fun. Let's see how it pertains to this graph.